Hello everybody, welcome back to another update. This is probably the final update of the stretch of outbreak that we've been seeing, or slash severe weather outbreak you could say, more so. And there's been, well actually first I think we should talk about it coming from yesterday's event, just to discuss like how it went and like the thoughts on it, because obviously we made our discussions in a previous video which you can check out as well. It was pretty in detail and covered quite a lot of the elements, and did accurately mention a lot of the different things that could come into fruition and what didn't actually come into fruition. And it was pretty much like on the lines of what actually happened and it came to fruition, which I'm really happy about in terms of the forecasting element and the understanding the dynamics. But so looking from yesterday's event, really what you could see as for what did pan out was a large, widespread severe weather event, talking about this MCS evolution to a QLCS with the progression of the troughing and the low-level jet, and then we're looking at whether there was going to be some sort of supercellular event at any point. QLCS tornadoes, the incredible wind shear that demonstrated by the Hodographs, and the extent of coverage and the narrow warm sector. And so one of the things we can probably mention first is how you could say it's underperformed. So one of the things we did identify during yesterday's video was that about the idea of a confluence boundary, or a boundary that's ahead, typically of where the leading cold front pseudo dryline was, and then it's this area of subtle convergence that is existing, that is usually due to some sort of back surface winds, and then you have more veered winds slightly, and those converge. And when you have those out in front, they typically initiate those in front of the line, a supercellular convection. And what really did not materialize was the actual supercellular aspect of it. Most of the time when it did happen, there was certain elements such as the cells forming and initiating, but then them being so like lackluster in the fact that the instability values were partially reduced due to cloud cover, and some of the cells were moving at a much slower pace relative to the line, the QLCS, overtaking them and merging in, and some of the cells, because of the parallel vectors, merging into each other. And as well as that, one of the things was the pinch warm sector and how it was removed from the low-level jet. So yeah, even if any storms did mature, they really did not feel the effects of the low-level jet to the point where they would have produced a more significant tornado had they have already produced a tornado. And one of the other things to identify was from a thermodynamic profile. When you're looking really at it, the instability was certainly reduced slightly, and one of the things also was the 60 to 75 miles per hour was the progression of like the storms from the initiating boundary. And what that really meant was anything that really, even in the line itself, such as the embedded supercells, did not get it, because tornado genesis is a very specific and dynamic process. So when you have such a fast moving progression and such clustering very quickly, even embedded supercells that did occur, there were several impressive looking ones, but yet they're all largely disturbed through the dynamics of such fast progression, multicellular ingestion and conglomeration, reducing the time required for the delicate balance of tornadogenesis to occur, and even allow for those supercells to mature enough and progress eastwards into the stronger shared environment. And really that did not occur. And also one of the things you could see was there's not many tornadoes that could have potentially occurred with the QLCS, despite their very favoured profiles on the wind shear side. That could partly be related due to the orientation of the boundary, and then relative to that, the Hodograph, the 0 to 3 kilometer vector, the direction that was facing relative to the line itself. And when you have a less of that parallelness with those vectors, you tend to have this really unfavorable part for QLCS tornadoes and kinks to form. And sometimes you don't even get any initiation, like any sort of kinks at all in the northern extent, even when there's really favoured sheared environment. And often those really strong shears can actually break down and lead to just more forcing, and those storms can produce stronger downdrafts. Those downdrafts can also become too intense, and sometimes it brings such a large cold pool that the storms themselves weaken over time as well. And so I think that's kind of like a discussion to yesterday's event, to miss the main point roughly. There were very strong gradient winds pushing the backside. You could see them by visual satellite. There was huge, almost dust swirl pushing from the north to south in near the critical fire region, where you could see that dust being blown by 80 miles per hour winds at least, as recorded. And so really that was something really interesting to see on satellite. Looking on here and currently what we have today, we have this very large extratropical system. It is considered anomalous relative to the normal pressures and the intensities that these extratropical mid-latitude cyclones can be, that progressed in March and early spring. And so relatively deeper pressure, and you can see this clear large swirl, the surface swirl. This is normally where you would associate your occluded front. You have the cold front down here, and then you have a little of a warm sector down here, a bit of a U-shaped marine sort of warm front that will be existing down to the south. And if there is any synoptic warm front, it'll be up to the north slightly as well. But then we have this line, there's still the same sort of progression. So new convection that's initiated, that's pushed through, a very fast progression. And currently around this time, we can start to see some of these more intense cores, likely where the most more intense winds are, and some larger hail. And there are a few tornado warnings that have been issued. And so we're just going to see the progression of this really. I was going to begin with the HRRR just to demonstrate what's going on, just to really give a perspective first. And really what we're looking at in the next period of time from 18Z to 0Z really, you can see a very some of these are like almost where helicity tracks will be most intense, so they'll demonstrate where there's a tornadic potential or even strong winds and hail, but mostly a tornadic potential in these certain updrafts that exist within the line, and not really any sort of superciliar ahead of the line sort of convection, but more so in the line itself. Embedded supercells are entirely a potential, but largely when you look at this, you're seeing that there is some of these robust cores that could develop and produce potential significant tornadoes, given that we've already previously discussed some of the the analogues to this event, and how it's kind of similar to those events, but they did produce some significant tornadoes in those. A bit different in the way those events were structured and the dynamics, but still pretty similar. So you can expect the potential of elevated tornado, an elevated tornado potential you can expect. Okay, and then what we have really now is the NAM to look at. Right, looking at the large scale, we can really just look at this part. Really, the evolution of the troughing. It was most mature in the earlier parts, where it was this very large, high amplitude, low frequency sort of significant negatively tilted troughing that's now starting to become more broad, diffuse, and the temperature gradients are becoming much more diffuse as well, and the winds are starting to become less intense as well over time, but still a very significant 500 millibar flow with above 90 knots potentially of this 500 millibar flow over the Carolinas, where the current severe weather event is at. Actually, I did not even show the graphic of today at all yet, which is a bit something that I should have thought about first. So yeah, the enhanced risk is just exactly what we're looking at, with 5% tornado potential and 30% unhatched risk, and we have a low hail risk. And with this, I think we're going to just go straight to this diagram again, just looking really at the evolution of this. So really still more so negatively tilted still, and a very large region in which it is favourable corridor for the severe weather potential. And again, whether you have the jet maxes, that's kind of that's exactly where the HRRR overlay the most robust cores to develop. So again, tornadic potential is entirely possible, and we see kind of a lot of offshore tracks from the HRRR, and that often does happen. But again, it does show it on inland as well, which is where the potential is really for significant tornadoes, and that could cause damage if not recognized from the pattern. But now looking at the 850 millibar, the low-level jet, again, very significant low-level jet still persisting. We're still looking between 70 to even 80 knots, really, and this surface winds will be really significant and backing all the with southerlies all the way up the coast, and this should fuel duration of where the QLCS that's moving rapidly along with this Jetmax, they should persist together and allow for potentially an elevated failure potential hotspots within the Carolinas, certainly where the wave echo pattern, so where the lines really bow out, have a potential to perform those kinks for those QLCS tornadoes, or should there be an embedded supercellular threat, because clearly a strong wind shear like this can support embedded supercells as well. And then the surface pattern, really, well, you can sort of see it here. I'm just going to look over from this sector. The surface low is up here now, but you can see slightly where this. So you got this clear temperature difference here, and you've got some subtle change in the winds as well. So you've got a very diffuse line where the boundary initiation is really pushing across as well. And you've got this cold upper level low, and you've got like a surface low in relatively close fashion. So you've got like somewhat of a cold core-esque, but then this is kind of considered pseudo because it's not necessarily a defined surface pattern where the defining features the thermal, any sort of thermal or temperature baroclinic, sorry. There's no really any baroclinic defined surface pattern with the frontal features, but we have here a significant pattern, like still with this sort of like pressure tunnel isobars here, tightly compact, strong winds on the back side as well, and we potentially could see. Well, really, we do actually see some southeasterlies and some southwesterlies. That's showing really strong convergence. So it's really the question if, I mean, this probably is where the line is going to be, and so this is probably how fast the progression of the line is. Yeah, so you can see how fast the progression of the line really is within those 3 hours, and within 0Z they're already off, like just about to reach offshore. So that should, and this could potentially again create like some sort of convectively enhanced shortwave troughing that could initiate more convection as well. Should that occur? Dew point. So the dew point evolution, the evolution of the way the dew point's even received within this region is largely from the Atlantic moisture that's persisting rather than the Gulf of Mexico acting as the moisture source. So we have this source to sink transport of moisture from the Atlantic, and you can see the way the winds are progressing northward and show some strong back surface flow, and you see this red lines here where the unstable mass is directly over where the QLCS will be. So there is this favored corridor, and with this we're just going to take a sounding as well in this region. We're going to look at really at 18Z is where we're looking at right now. 21Z is where we have that potent potential. And we're going to do it slightly northward extent as well, and we can do southern extent as well, but I don't think it'd be all too favoured on the very southern extent compared to the northern extent. And then 0Z again, we can kind of look out here, maybe in the outer banks somewhere here. Alright, so we're just going to begin with the first sounding. This is the one in North Carolina. We can see, well, again, not really a significant kinematic profile or thermodynamic profile from this sounding, but like certain things we can pick out at least. So you have this, in ignoring some of the feedback, we see some instability within the mid levels, and again cold core, so there could be this elevated potential with the cold air acting as a way to increase the mid level and its surface instability, 3 kick values exceeding almost 100 joules per kilogram, and that's going to be largely a large percentage of the total instability, which should attribute to increased potential of that vorticity stretching, and that the low cloud cover with that low LCRs being stretched efficiently, producing potential spin-ups. But then we see this very linear, like unidirectional flow within most levels of the atmosphere between 1,000 to even up to probably 700 millibars at least. You can see this unidirectional flow, and that is largely going to be unfavorable, slightly well, I say slightly and largely, but more so largely it's going to be unfavourable. One thing though is if we have a linear progression of the line, and then we have this sort of unidirectional wind profile, it could still be favourable in the direction that it's oriented relative to the line, and so that should allow for some spin-ups. They don't have to be significant to cause significant damage. Correlation, not causation, so we can clearly see the potential for that to occur. But then with the next observation, we're looking slightly more north, probably much less favourable really from a thermodynamic profile as well. Now I think we should look at the southern side again. Almost the same thing. We don't really see anything else to differ about. Actually, one thing we can observe is actually a bit more of an influence. We see even more 3K. That could be potentially due to surface, the way the surface heating is, and we see that cold core setup, and we see the fact that a lot of that instability that will be distributed will be now brought to the surface levels, and really regulated into the surface levels as well. And largely, I think that this is all going to be the same. Yeah, this is all going to be the same. So really just a moderate profile, really actually compared to what the different analogs were suggesting, which had a much more robust wind profile. What those wind profiles really showed was more of a varying within the winds particularly, and that really contributes to the area underneath the curve with the inflow, where you have this inflow vector. You saw much more SRH, so where it's much more of this effective inflow layer of this helicity, and then we see that there's still a moderate amount, but it was much more significant as analogs. So from a relative perspective, that those outbreaks had much more of a favourable kinematic profile. But this is still a potential to produce a significant tornado, given that there's probabilities, and even with subtle interactions on a mesoscale level, they can affect the balance between producing the non-significant and significant tornado. So that can also occur. And with this, I think everything I've already said describes what is really needs to suggest what's going to happen for this event. And then looking just further out, there were some discussions on March 15th, etc., for the more significant outbreak, and that will again be some point to notice just when we could look for more severe potential to discuss in the future, and when there will be a day one outlook on that time period, we'll do an update should that be the case, just because I've seen a couple of those posts, so it just brought my interest. But with that, I think I'll see you guys in the next update.